this video, I will explain about the overview of compilers, that is, what is compiler, what is interpreter, what are the main differences between compiler and interpreter, the several other programs which may be required to create an executable target program, and the different phases of compilation. Now, what is compiler? Compiler is a program that reads a program written in one language, that is the source language, and translates it into an equivalent program in another language, that is the target language. This is the block diagram of a compiler. The compiler takes the source program. If there is any error in the source program, it generates the error messages, and then if the program is error free, generates the target program. The target program takes the input and generates the desired output. So the compilation is the translation of a program written in source language into a semantically equivalent program written in a target language. On the other hand, an interpreter takes the source program as well as input at the same time. If there is any error in the source program, it generates the error message. If the source program is error free, the interpreter generates the desired output. So, the basic differences of compiler and interpreter is as follows. A compiler is a program that translates an executable program in one language into an executable program in another language. On the other hand, an interpreter is a program that reads an executable program and produces the result of running that program. This is a block diagram of complete language processing system. Along with the compiler, there are several other programs are there. They are preprocessor, assembler, and linker. Skeleton source program is taken as an input to the preprocessor. The preprocessor reads the skeleton source program and translate the equivalent source program for the skeleton source program. Where the source program is passed through the compiler, and the compiler generates the target assembly program for the source program. Then the target assembly program is passed through the assembler, which generates the relocatable object code. The relocatable object code is passed through the linker, and the linker do the linking between the libraries and other relocatable object file, and finally absolute machine code is generated. So in the language processing system, the other programs, preprocessor, assembler, and linker, it works along with the compiler to generate the absolute machine code, which is also known as the cousins of compilers. That is, preprocessor, assembler, and linkers are the cousins of compilers. In this block diagram, the different phases of compiler has been shown. Basically, there are 6 phases of compilation. There are lexical analysis phase, syntax analysis phase, semantics analysis phase, intermediate code generation phase, code optimization phase, and code generation phase. So, the phases of compilers are lexical analyzer, syntax analyzer, semantics analyzer, intermediate code generator, code optimizer, and code generator. The source program is given to the first phase of the compiler, that is the lexical analyzer phase, and code generator phase generates the target program. The error handler program is attached with all the phases of the compiler, and the related error messages are generated in each phases of compilation. The phases of compilation basically divided into two parts. One is the analysis phase and another is the synthesis phase. The first three phases are known as the analysis phase, whereas the last three phases are known as the synthesis phase. In the analysis phase, the compiler breaks up the source program into pieces and imposes a grammatical structure. In this phase, compiler creates the intermediate representation of the source program. It determines the operations and records them in a tree structure which is known as the syntax tree. The first three phases of compilation, which is also known as the analysis phase, is known as the front end of the compiler. So, analysis phase is also known as the front end of compiler. Now, the last three phases are known as the synthesis phase. In this phase, synthesis phase constructs the target program from the intermediate representation. It takes the tree structure and translates the operation into the target program. The last three phases, that is synthesis phase, is also known as back end of compilation. Now, suppose we have an input expression like position equal to initial plus rate into 60. So, this is the syntax tree or parse tree generated by the analysis phase. Rate into 60 is calculated first, then it is added with initial and the total value is assigned to position. Analysis phase is the first three phases, and I have already mentioned. The first phase of analysis is the linear analysis. Here, the streams of characters read from left to right and grouped into tokens. Each tokens are identified in this phase. It is also known as lexical analysis or scanning. The second phase of analysis is the hierarchical analysis phase. Here, the tokens are grouped hierarchically with a collective meaning known as parsing or syntax analysis. The third phase of analysis is the semantic analysis phase, which check if the program component fit together meaningfully or not. Here it is shown how the tokens are identified in the lexical analysis phase. Suppose we have an input expression position is equal to initial plus rate into 60. So, scanning is done from left to right. In the left side there is position. So, position is identified as identifier position. Then we have equal to symbol, which is identified as the assignment symbol equal to. Then we have initial. Initial is identified as identifier initial. Then we have plus. Plus is identified as plus sign. Then we have rate. Rate is identified as identifier rate. Then we have multiplication symbol, which is identified as multiplication sign, and then we have 60, which is identified as number 60. So, all the tokens are identified in the lexical analysis phase. The next phase is the syntax analysis phase, which is also known as parsing or hierarchical analysis. Here, grouping of tokens is done. Okay, so tokens are grouped into grammatical phrases. The character groups recorded in the symbol table. The tokens are represented in this way as a parse tree. Rate is an identifier, which is an expression. 60 is a number, which is again an expression. These two expressions are multiplied, and again we are getting expression into expression, that is expression. Initial is an identifier, which is an expression. then expression and expression are added and we are getting another expression. Then this expression is assigned to the identifier position. There are several rules how we can define an expression. Any identifier is an expression. Any number is an expression. If expression 1 and expression 2 are expression, then we can say that expression 1 plus expression 2 is the expression and expression 1 into expression 2 is again an expression. Hierarchical structure usually expressed by using the recursive rules. The third phase of analysis is the semantic analysis phase. In this phase, it checks source program for semantic errors. It gathers the type of information for subsequent code generation, which is also known as the type checking. It identifies operator and operands of the expression and statements. Now, what is symbol table? Symbol table is a data structure with a record for each identifier and its attributes. Attributes include the storage location, type, and scope. All the compiler phrases insert and modify the data in the symbol table. Symbol table management is storing and modifying the data in each phases, which is done by the symbol table manager. Now, the next phase is the intermediate code generation, which is the first phase of the synthesis. Here the program representation for an abstract machine. It should have two properties. First one is easy, it should be easy to produce and it should be easy to translate into target program. Here the 3 address code is generated. 3 address code is commonly used form of intermediate code generation, which is similar to the assembly language code. About the 3 address code we will discuss during the intermediate code generation phase. Now, the last two phases of compilation are the code optimization phase and code generation phase. In the code optimization phase, the intermediate code is improved by producing code that will run faster. And the last phase is the code generation phase, where the target code is generated. The target code is either a machine language code or a assembly language code. Here the structure of a compiler is given. Position equal to initial plus rate into 60. This is the input expression. Identifier 1, identifier 2 and identifier 3 are the position, initial and rate respectively. Plus and multiplication are the two operators and equal to is the assignment operator. So, the tokens are identified as identifier 1 equal to identifier plus identifier into 60 numeral. Then the parse tree is generated when it passed through the parser in the syntax analysis phase. Identifier 3 into 60, it is multiplied, then added with identifier 2 and the value is finally assigned to identifier 1. Then in the semantic analysis phase, when it passed through the semantic analyzer, then abstract syntax tree is generated. After that, in the code generation phase, intermediate code generation phase, intermediate code is generated. Here the number is assigned to temp1, then temp1 is multiplied with identifier 3 to generate temp2. Then temp2 is added with identifier 2 to and assigned the value to temp3. Then temp3 is assigned to identifier 1, which is the final result. Then it passed through the code optimizer and the 4-line code becomes a 2-line code. Here identifier 3 is multiplied with 60 to and assigned the value to temp1. Then temp1 is added with identifier 2 and assigned with identifier 1. Then finally it passed through the code optimizer field and this code is generated. This is a target machine code. Here identifier 3 is moved to R2. Then it multiplied with 60 and again the value is assigned to R2. Then identifier 2 is moved to R1. R1 and R2 is added and the value is stored in R1, that is register 1, and then finally the register 1 value is stored in identifier 1. So this is the structure of a compiler. Here this is the source code, position equal to initial plus rate into 60, and this is the target code. Now basically we can all the phases of compilation we can divide it into two phases. One is the front end and another is the back end. The analysis phase is the front end, that is syntax analysis, semantic analysis, and lexical analysis. So lexical analysis, syntax analysis, and semantics analysis are the front end of compilation, and the code intermediate code generation, code optimization, and code generation is the back end of compilation. So front end and back ends are like this. Analysis steps for intermediate code generation depends primarily on the source language and machine independent. Whether back end is the code optimization and code generation phase basically under back end, independent of source language, and it is machine dependent. Now there are basically two passes of compiler, either it is single pass or multiple pass. Here the if a collection of phases is done only once in single pass or multiple times in multipass. So what is single pass compilation? Here reading input, processing and producing output is done by one large compiler program, which is usually runs faster. But in case of multipass, the compiler split into smaller programs, each making a pass over the source performs better code optimization. So this is the basic difference between single pass and multipass compiler. Now these are the different compiler construction tool: scanner generator, parser generator, syntax directed translation engines, automatic code generator, data flow engines, etc. And that's all about the overview of compilation. Thank you.